replaceable hydrogen atom. It contains one replaceable hydrogen ion, sorry. It's going into the base that side. Second point, because I have to fit it in, I'm not writing that. Second point is that it dissociates in one step. It dissociates in one step. See how it has dissociated in one step only. It took just one step to dissociate into hydronium ion and nitrate ion. So it dissociates in one step. And finally, the third characteristic is what? That it produces only one type of salt, that is normal salt. It produces only one type of salt. And what is that type? That is a normal salt. A normal salt. Let us see one example. HCl, suppose. HCl, it is, here only I am fitting it somehow. HCl plus NaOH forms NaCl plus H2O. So it's producing only one type of salt, one salt, that is a normal salt. When we do the classification of salts, the next chapter, then you'll understand what is a normal and acid salt. This is dissociating in one step and it is producing only one type of salt, that is NaCl. That is a normal salt. So monobasic acid furnishes only one hydrogen ion per molecule of acid. One molecule of acid will produce one hydrogen ion. It dissociates in one step, a single step process. Next is it produces only one type of salt, that is a normal salt. In the bases also it's the same. Bases contains only, dissociates in, here furnishes H plus, so it furnishes OH minus. Only it furnishes what? Only one OH minus ion. Dissociates in a single step, so NaOH will dissociate into Na plus OH minus, single step, and also it reacts with one acid molecule only to give salt and water. Here see, it is reacting with only one molecule of HCl to give salt and water. That's another reason why this is called basicity of an acid. The acid reacts with only one base molecule to form salt and water, so monobasic. Here also the alkali reacts with only one acid molecule, so monoacidic base. It is called a monoacidic base, or we can say acidity of the bases. Acidity is equal to 1. Acidity is equal to 1. Now we go to the dibasic acid. Dibasic acid, this is number 2, dibasic acid. Dibasic acid will furnish 2 hydrogen ions or hydronium ions. Let us take an example. And this dissociates in 2 steps. I'll give the example just now. It dissociates in 2 steps and it produces 2 types of salt. It produces 2 types of salt. One is a normal salt and the other is a acid salt. Normal salt, acid salt. Now we will discuss this in details. Let's see this one. Furnishes only this furnishes 2 hydrogen ions or hydronium ions per molecule of acid. Suppose H2SO4. How many hydrogen ion it will furnish? 2. This will furnish 2H plus SO4 2 minus. So per molecule of acid 2 hydrogen ions or hydronium, you can write H2SO4 plus H3O also, you get 2 hydronium ions. Next it dissociates in 2 steps. Let's see how it dissociates in 2 steps. I'm rubbing this out. Dissociates into, first step it dissociates into H2SO4, dissociates into, this is the first step, it dissociates into H plus, or let us take the aqueous solution. H2SO4 plus H2O, aqueous solution. This is dissociating into H3O, 1 hydronium ion, and HSO4 bisulfate, HSO4 minus. Next step, again, this HSO4 minus plus H2O, the second step. This is again furnishing another H3O ion plus sulfate, 2 minus. Sulfate ions are 2 minus, you know that. So in 2 steps it dissociates. In the first step it is producing a hydronium ion and HSO4 bisulfate ion. That bisulfate ion again dissociates in water to give hydronium ion and SO4 ion. So ultimately how many hydronium ions are produced? H3O, H3O. This and this cancels off, this and this cancels off, and you get H2SO4 plus 2H2O is 2H3O plus SO4 2 minus. It produces 2 types of salt. We can write this complete equation, H2SO4 plus this 2H2O, this and this has cancelled out, 2H2O, this forms 2H3O plus sulfate 2 minus. Now it produces only 2 types of salt. This I am again writing down over here clearly. Third step is it produces 2 types of salts. One is an acid salt and the other is normal salt. So H2SO4, a dibasic acid, first reacts with one molecule of an alkali or a base, and this gives an acid salt. Only one hydrogen from this is replaced. Remember the bisulfate, so it gives NaHSO4, sodium bisulfate plus what? This is NaHSO4 is produced over here plus water. Salt and water are the products. Acid, this is a neutralization reaction. So acid and alkali giving salt and water, NaHSO4 and H2O. And if there's another type of salt produced when it is reacting with neutralization. This is partial neutralization only. Only one of the hydrogen is displaced. So NaOH, 2NaOH, this gives on complete neutralization, it will form Na2SO4 plus H2O. So what, see, this is a normal salt, there is no hydrogen present in this. Here there is a hydrogen present which can be further replaced. So this can be displaced, this can be replaced again. So this is an acid salt. It is called because some of the acidic characters still left over. Here the NaHSO4, this is an acid salt, and this is a normal salt. This is a normal salt. So dibasic acids will furnish 2 hydronium ion per molecule. It will dissociate in 2 steps and it will produce 2 types of salts when it is neutralized with a base. 2 molecules. For complete neutralization it needs 2 molecules of base. That is why dibasic acid. For diacetic bases, what are the examples of diacetic bases? NaOH, KOH is monoacetic base because they contain only one replaceable OH ion, hydroxyl ion. Suppose CaOH2. CuOH2. These have an acidity of 2 because they are diacidic bases. They are called diacidic bases. And if they are soluble in water, then they will furnish 2 hydroxyl ions. And if they are insoluble in water, we just count the number of OH ions present in the molecule and we say that it is a diacidic base. Now try basic acids. Try basic acids like H3PO4. This will ionize in 3 steps and they will furnish 3 hydronium ions per molecule of acid. H3PO4 will form 3 hydronium ions, will react with, so we will, I will show the dissociation reaction first, how it dissociates. It dissociates this plus H2 of course. One hydronium ion and the other is H3PO4, first dissociation, next dissociation. This H2PO4 further dissociates into a hydronium ion and HPO4, 2 minus. Now this HPO4, 2 minus, this again dissociates and forms, there's still 1 hydrogen left, so it will furnish another hydronium ion, H3O plus, and PO4, 3 minus, and phosphate, 3 minus. Altogether, if you write the overall equation, this and this cancels, this and this cancels. So we have H3PO4 plus 1, 2, 3 H2O furnishing 3 hydronium ions plus phosphate ion. So it dissociates in 3 steps. It's able to furnish 3 hydronium ions and it dissociates in 3 steps. Now the salts that they produce. They will produce 3 types of salts. 2 acid salts